All right, welcome back. So now let's move into the next section of our chapter for rational functions to talk about a little bit more graphing rational functions. So what I do to kind of start this lesson is just take a look at three different rational functions and kind of see how they're going to differ from one another in terms of their asymptotes. So I asked students to kind of look at, up to this point, we've talked about how to find the x-intercepts, how to find the y-intercepts, as well as how to identify the vertical asymptotes. Now you can see I have the horizontal asymptotes here because at this stage, I kind of went back and showed them the graphs, but we're going to go and take a look at the graphs. I just want to make sure we focus on right now looking at the x-intercepts, the y-intercepts. Again, how do you find those? X-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. Now, it's also important for us to kind of look at the shortcuts here because I only showed my work here in the first example. For these next two examples, I didn't show my work. So how did I figure out those answers? Well, again, if you notice, when you're finding the x, when you set y equals 0 for a rational expression, the first step you need to do is multiply the denominator on both sides. And if you're multiplying the denominator by 0, then really to find the x-intercept, you just need to take the numerator and set it equal to 0, right? And students will get this confused because when you set the denominator equal to 0, that's how you find the vertical asymptote, right? If you want to find the x-intercept, you set the numerator equal to 0. Kind of gets a little confusing, but I think if you can just remember x-intercept, y equals 0, and then y-intercept, x equals 0. And what this produces is when you plug 0 in for x, what that leaves you with is just your constant over your constant. So again, you can really kind of streamline this a little bit quicker and get a faster response just by taking your constant over your constant to find your y-intercept. And again, these can be written as coordinate points, but I just wanted you to see them so we could verify. The vertical asymptote, you can see you just set it equal to 0, and then you go ahead and solve. Notice there's two of them, plus or minus 2. Now, you can see the difference between these. The numbers and variables are the same. The only thing that I changed is the powers. And that's what we're going to look at with these graphs, is how does changing the powers in the numerator and the denominator impact the graph, right? Because the numbers don't change, but the graphs are definitely going to be different. Now, when I have an x squared, now we have two x-intercepts. We still have one y-intercept. I still have two vertical asymptotes, right? So you can see that's going to be changed, but now I have two x-intercepts. How's that going to look? Over here, you can see that when I have an x squared minus 1 or the x minus 4, so now I still have my two x-intercepts. I still only have one y-intercept, but now I only have one one vertical asymptote. So what we're going to do is we're just going to kind of look at these. And the first one we'll do is the x minus 1 divided by x squared minus 4. All right, so I want you guys to see there are those two vertical asymptotes. We have our one y-intercept and our one x-intercept. And you can see that that is where we found this horizontal asymptote at 0, right? So what we're going to do is we're going to kind of investigate this further for this chapter. Why is there a horizontal asymptote there? We know how to find the vertical asymptotes. We know how to find the x and the y-intercepts, but how do we know there's a horizontal asymptote at 0? And you can see as this graph approaches, it keeps on getting closer and closer to 0 from the left and from the right. In this case, now we have two x-intercepts, one y-intercept. We still have our two vertical asymptotes, but now it doesn't look like the graph is approaching a horizontal asymptote at 0. It looks like it's approaching a horizontal asymptote at 1. And one thing we do in Desmos is I'll keep on expanding out, and you can see that, yeah, it is approaching the value y is equal to 1. And again, so what's the difference? The only difference between these two equations is the top equation became squared instead of linear, right? So interesting. And then the last equation is now I'm making my denominator linear and my numerator is quadratic. And it doesn't look like my graph is approaching any horizontal line. It looks like it's approaching a diagonal line, right? So just some kind of interesting things. It doesn't look like there is a horizontal asymptote in this case. And that's going to be some of the things that we're going to investigate in this chapter. And if you remember, the rational functions come from our reciprocal function. And the reciprocal function, if you remember, f of x equals 1 over x, had a vertical asymptote at 0 and a horizontal asymptote at 0. And we'll use this understanding of the reciprocal function to help us graph our rational functions, as well as understand the characteristics of our rational functions. So in this chapter, we're going to look at identify vertical asymptotes. Again, that's going to be when the denominator is equal to 0. Make sure, though, it's not a whole, right? Because it has to be a non-removable discontinuity for it to be a vertical asymptote. we'll look at the horizontal asymptotes, and hopefully at this point you notice that the horizontal asymptotes are when the graph is approaching a horizontal line. And the way that the horizontal asymptotes are going to change is we're going to have a horizontal asymptote test. And what we're going to look at in the next video is that the horizontal asymptotes occur based on the powers in the numerator and the denominator. And then we're going to talk about the oblique asymptotes, and that was that diagonal asymptote. A lot of times, sometimes we'll call them the slant asymptotes. We're going to look at how to find those, when they occur, and when they occur, and how to find them, as well as graph them. And then last but not least, we'll talk about the x and the y intercepts. Again, remember, it's very important to drill this into your brain. X-intercept is when y is equal to 0. Y-intercept is when x equals 0. But if you want the shortcut, when you're just trying to find the x-intercepts, that's going to be the numerator equal to 0, and when you want to find the y-intercept, that's just going to be the constant over the constant. So we'll also take a look at symmetry when we want to graph them. I'm not a big proponent of graphing rational expressions because, at least in my class, we use a lot of technology, but I will at least explain how symmetry can be useful when graphing rational expressions. So there goes. There you guys have it. We will have a lot to kind of cover in this section, but I want you to understand when we're graphing rational expressions, one, we need to understand the characteristics of irrational expressions in terms of the asymptotes, the intercepts, and just evaluating points as well as symmetry. And we will identify all that information to be able to create the best version of a rational expression that we can for graphing. So we're going to look at identifying the parts as well as creating a general sketch based on transformation and our knowledge of all of those parts coming together. So now the next thing I'd like you to do is go ahead and take a look at the notes where we'll go back and review the reciprocal function as well as how to identify the asymptotes and the intercepts of a rational expression. And then it'll be time for you to practice. And what we'll do is we'll work on identifying all these parts as well as graphing rational expressions. And again, remember, you can always check your answers inside those process videos as well as with my quick quizzes inside of the course. I'll see you guys in the next video. Cheers.